Okay, this is what's called a system of equations, and you solve them by what's called elimination. And there's some tricks to making the problem shorter. A lot of times they're long, but what you want to look for is basically there's three variables, x, y, and z. And what you're looking to do is cancel variables out by combining equations. Now there's three equations, equation 1, equation 2, and equation 3. And they often try to set you up by tricking you to make it look a little harder than it has to be. I'm going to pick two equations, and if I add them, some variables are going to just disappear. So usually it's equation 2 and 3 or 1 and 3. Here it's these two equations. I'm going to combine these first. I'm going to add them because the negative 5y and the positive 5y are going to cancel out. Let me show you what I mean. I'm going to go write those two equations on the next page. Hold on one second. So I want to be careful because I move these over here. Basically, what's going to happen is I'm going to combine two to get it down to one variable, then use that variable to put all three of them back together, so I can solve them all. Let me show you what I mean. Okay, I'm going to come over to these two equations. These are the second two. Okay, so I chose these two equations so I can add them together. And when I add them together, I get negative 4x. These cancel, equals 16. Then I'm going to divide each side by negative 4. And I end up with x equals negative 4. So I've now solved one of the variables. That's it. But I'm going to use that to get more information in a moment. Okay, so we combined those bottom two equations in the first step because it was easy to combine them. Okay, now we have to combine the first equation and any other equation. This is true on any type of these problems. All three equations have to be combined, so I'm going to grab these two equations this time and connect them together and solve them with the other information I have. So let me flip to a new page. I know it's a lot of steps. It really is. I'm not denying that. I'm going to go to here. Okay, we're now going to combine these two equations. We'd like to add them. I don't know if we can. Before we go on, we're going to take this new piece of info we have. We already know x is negative 4, so I'm going to fill that into the x spot. So the first step was to combine two equations, solve for one variable. Doesn't matter which one. Now we're going to fill this number in. We get negative 16. Ooh, who said negative 16? Positive 16. Minus 5y. Minus z equals 18. And he may show it to you in different steps. That's absolutely fine. Doesn't matter. And then we've got 8 minus 5y minus 2z equals 12. Now, I'd like to combine these so another variable disappears. If I add them, we're going to get negative 10y in the y column and negative 3z in the z column. So combining them that way doesn't help me. I can use any operation I know, addition, subtraction, multiplication, or division, to make it happen. If I subtract the second one, turn this to a minus, turn this to a plus, turn this to a plus, turn that to a minus, you'll see that one of the variables now cancels out. You're always looking to cancel out a variable each time. That's why in the beginning, I'm going to step back. I know I'm jumping around. These problems, there's no way to not jump around. In the beginning, I combined these two by adding, because when I did that, these things and these things went away. So let's come back to where I am. So I'm adding these now. Oh, that variable is gone. Okay, and I get negative. Let me go to a new page here. I get 8 plus z equals 6. I'm going to bring that to a new page. 8 plus z equals 6. To get z by itself, I'm going to subtract 8 from each side. And I get z equals negative 2. So now I have two variables solved for. I know x equals negative 4. I know z equals negative 2. And now I can use those two pieces of information in any equation. Doesn't matter which one. Here's why it doesn't matter. I'm going to go back for a second here. Because in the very first step, I combined these two equations together, so that brought those two together. And I've colored in the orange on purpose. Then on the second step, I brought these two equations together. Once that's happened, I've combined all the equations into one. So now I can use any one to solve for z. I'm going to choose the last one. Doesn't really matter. I'm going to come write that down. Okay, so here's the information I found in the 2 steps before this, and all these problems will be this long. And I picked, after that, in the end, any equation to work with. So I've got negative 2x plus 5y plus 2z equals 4. I'm going to use the numbers I have and fill them in. So negative 2 times negative 4 is 8 because of that x, plus 5y plus 2 times negative 2, let's get rid of that minus sign, is negative 4 because the z is negative 2, equals 4. So I'm going to combine these equations and I get 4 plus 5y equals 4. Subtract 4 from each side. 5y equals 0. So y equals 0. Okay, so now I found the x value, the y value, and the z value. So to make it specific, to make it generic for any problem, if you're given 3 equations, 1, 2, and 3, the first thing you're going to do is combine any 2. And you're going to combine the easiest 2, ones that you can add together and make something cancel out. That's why I combined, oh, so many steps, sorry. That's why I combined these 2 equations first, because one variable then was solved really easily. So first you combine any 2, and then you have to combine the leftover equation with either of the 2. You do whatever's easiest. Usually it involves subtracting. Once those 2 are, what's going to happen when you combine 2 and 3, you're going to find one variable. Then you can combine the first equation and another one, you're going to find the second variable. Once you have those 2 variables, you can put those in any equation, and you will find the third variable. I know it's a lot of steps. Don't overthink it. Combine 2. Combine the one you haven't combined with another, and then stick the one into the equation, and you should be able to get an answer. I hope this helps. Take care.